Hello, in today's lesson we are going to expand upon what we learned in the previous lesson about the equations of circles. Before we expand upon yesterday's lesson, let's first take a look at what we did yesterday. Take a moment, pause the video now, and see if you can answer exercise 1. Okay, so from yesterday's lesson you should see that the center of letter A is 0, 0, because it's x squared plus y squared, and the radius is 10. The square root of 100 is 10. Letter B, you should have had 5, positive 2 as your center, and a radius of 6. Square root of 36 is 6. And letter C, your center should be negative 2, positive 11, and your radius is the square root of 1, should be 1. So that was what we learned yesterday. Today we're going to apply a certain technique called completing the square, because sometimes the equation of a circle is not written in a nice way to find the center and radius, so we have to manipulate it in a certain way. So before we do that, exercise 2 asks us to refresh our skills from Algebra 1 and how to solve an equation using the completing the square method. So I'm going to discuss how this method is worked in exercise 2, and we're going to apply it to exercises 3 and beyond. To complete the square, what you want to do is you want to isolate the variables on one side and the number term on the other side. So what I'm going to do is I'm going to add this 39 to both sides. And when I do that, I'm going to leave a little blank after the x squared plus 10x. Because the goal in completing the square is to write an expression where it's some quantity of x plus some number to make a perfect square. Or you might want to have x minus some number quantity squared. Now to think about this, I'm going to look at an example where I have a perfect square and work my way backwards. So if I had x plus 2 squared, actually let me think about a better example. Back. X plus 5 squared. If I were to square that out, it's really the same thing as x plus 5 times x plus 5. Applying the FOIL method, which I prefer not to use, but distribution method is probably a better way to say it, I'm going to distribute that first x to both the x and the 5 of the second term, so x squared plus 5x. And I'm going to distribute that second 5 to the x plus 5x, so that gives me another 5x plus another 25. Combining like terms, we get a trinomial that is x squared plus 10x plus 25. Now if you look at how this trinomial is written, compare it to the original problem, x plus 5 squared, this number term is the square of that number in the parentheses. This x term is twice that number in parentheses. So in completing the square, my goal is to find some number here that creates a perfect square. To do that, looking back at the example above, that number right here was double this number right here. Or in other words, this number that I want is half of the number in front of the x in the trinomial. So if I take this 10 and divide it by 2, it gives me a positive 5. But in order to complete the square, what I'm going to do is I'm going to fill that blank in with the number that makes it a perfect square. And that number is going to be 5 squared, which is 25. But in order to balance the equation, I need to add the 25 to the other side as well. And in adding that to the 39, that gives me 64. To finish solving this equation, what I would then do, since I have a perfect square on both sides, this is a perfect square, 64 is a perfect square. This is a perfect square because it's raised to the second power. I'm going to take the square root of both sides, and when doing so you have to remember that you have a plus or minus 64. Square root of 64, which is the same thing as plus or minus 8. Because I have a plus or minus, that gives me my two solutions. So what I'm going to do is I'm going to set the x plus 5 equal to a positive 8 and set the x plus 5 equal to a negative 8 to solve for my two solutions. Because it could be positive 8, it could be negative 8. Solving this further, I get x equals 3 Solving the other one further, I get x equals negative 13. Those are my solutions applying the completing the square method. So what I want you to do now is pause the video and take a moment to try letter B on your own, and then I'm going to walk through it with you. So pause the video now and try letter B on your own. Okay, so the first thing you want to do is you want to add that constant term to both sides of the equation, leaving me with an x squared minus 6x and leaving a blank so I can complete the square on both sides. What I'm going to do to complete the square is I'm going to take half of that 6, and I'm going to take actually half of the negative 6 to make a negative 3. Squaring the negative 3 makes a 9 that I have to add to both sides to make a perfect square trinomial. 7 plus 9 is 16. Take the square root of both sides. Don't forget the plus or minus. X minus 3 is equal to plus or minus radical 16, which is plus or minus 4. So x minus 3 is positive 4, or x minus 3 is equal to negative 4. Solving this further, x is going to be 7, or x is going to be negative 1. Those are my two solutions. Hopefully you got those. If not, we're going to have more practice in the next few problems. Pause the video now, write down anything you need to before we move on to the next example. Alright, so now let's see how this is applied in the equations of a circle. Now this equation right here in exercise 3 does not look like what we saw yesterday. We can't easily find the center and the radius, but what we can do is apply the completing the square algorithm to this equation to manipulate it to create perfect squares where one of them has an x and one of them has a y, and that's going to help us find out what the center and radius are going to be. So we're going to have plus some number or minus a number, plus or minus some number. Then once we complete the square for the x's and complete the square for the y's, we get our center and radius form. So what I'm going to do here is I'm going to group the x terms together and the y terms together, leave a space to complete the square for both of those variables, and I'm going to make sure my number term's on the right side. Luckily for me, we're starting off nice and easy. The number is on the right side. So I'm going to group the x squareds together, which they kind of already are, but I'm going to add a plus blank because I have to complete the square for the x's. Then I'm going to group the y's terms together, so y squared minus 8y plus some blank, because I need to complete the square of the y's. But since I'm completing the square twice, I'm going to add 2 blanks to that 5. Now what I'm going to do is I'm going to go ahead and write this parentheses. Sometimes it's good just to start doing that. Instead of trying to figure out what number goes in the blanks, I personally think it's easiest to think about what this number is, divide that by 2. So negative 4 divided by 2 is negative 2. Then square that negative 2 to find out what goes in that blank, which is positive 4. Don't forget to add it to the other side as well of the equation. Half of negative 8 is negative 4, so in the set of parentheses here is going to be negative 4. Squaring the negative 4 gives me a positive 16. By the way, notice anytime you have a positive or a negative, doesn't really matter what sign you have, the result is always positive. You should never have a negative numbers in these blanks. Don't forget to add the 16 to the other side. If I add the 5, the 4, and the 16, that gives me 25. Hey, look at that. There's an equation that I'm more familiar with from yesterday's lesson. So from now we can find out the answer to part B. What is the center and the radius of the circle? Go ahead, see if you can write those down right now. Okay, if you got 2 comma 4 is the center and 5 is the radius, then you're looking good. Part C asks us to graph the circle on the grid to the right. Now to graph circles, you could use your compass to do that. That's probably the easiest way. But sometimes, especially if you have a compass that has configured settings for a radius, like for instance the ones that have the holes in them. There's a compass. Sometimes you won't have a nice circle. It won't go through the points nicely. So I'm going to show you a little technique to draw circles. First thing you want to do is plot the center. So 2 comma 4 is going to be your center point. And then you're going to at least plot 4 points to the left, to the right, up and down. And you're going to use that radius to find out where those points are going to be. So to the left, 1, 2, 3, 4, 5. There must be a point on the circle. Up, 5. There's another point on the circle. To the right, 5. There's another point. And down 5. There's your last point. Now what I'm going to also show you, because typically most circles, those are only 4 points you need. But with a radius of 5, there's actually something special going on in this triangle that you can actually plot 8 more points. And this is going to be very helpful in some situations that you might see later on. If I look at a right triangle, so if I have a right triangle and I have a radius of 5, there's a special right triangle that have integer lengths for the legs. And you may remember that's going to be the 3, 4, 5 triangle. 3 squared plus 4 squared is equal to 5 squared. 9 plus 16 is 25. I can use that triangle as well as the one where it's over 3 up 4 to plot 2 more points in each quadrant of the circle. This only works for radius of 5 because these are special right triangles with a hypotenuse of 5. So what I can do is I can plot 2 more points by going to the right 3 up 4 to get to this first point I'm plotting right now, and then to the right 4 up 3 to get this point right here. There's another point. And then do the same thing all the way around the circle, and that actually creates nice points for you to draw the circle through, and then it's going to be a little easier to draw your circle freehand if you have those extra 8 points. Oops. Let me draw that a little better. Look at that. Oh, I keep going beyond the circle. Okay. I'm limited to this iPad that I'm working with. All right, so there's your circle. Now, it's not necessary that you do it if you just ask to draft a circle, but maybe you'll see later on that technique is going to be really helpful. Okay, so pause the video now, write down anything you need to before moving on to the next set of examples. Now let's look at some practice. So these next 4 examples are all just more practice writing your equations into standard form, sometimes called center radius form. So to do that, we're going to complete the square. So you got to make sure the x's are grouped together, the y terms are grouped together, and the number term is put to the right. So we'll do this first one together. And then I want to see if you can try letter B on your own. Then we'll do letter C together, and you'll try letter D on your own. So here's letter A. You want to group the x terms together. So we have an x squared plus an 8x. They're already grouped together, which is really nice and convenient. Add a plus blank. We've got to complete the square of the x's. Do the same thing for the y's. Group the y's together. And the number term is always already on the other side, so I'm going to just add plus blank to that negative 16. My next step that I'm going to do is I'm going to go ahead and set up my parentheses with the perfect squares, with the x's and the y's. Then I'm going to take half of 8, which is positive 4, square it. I get positive 16, add that to the other side as well. Looking at the y's, half of negative 4 is negative 2. Square the negative 2, I get a positive 4. Add the positive 4 to both sides. And that means when I add the negative 16 and the 16, hey, that's convenient, they cancel. I'm left with just 4 when I add 4 to it. So there's the equation in center radius form, in standard form. Now I'm just asked to find the center and the radius, which is something you're really good at from yesterday's lesson. So the center is going to be negative 4 comma 2, and the radius square root of 4 is 2. So go ahead, pause the video now, and try letter B on your own. All right, let's check to see how you did on letter B. So you should have grouped the x's and the y's together. So I'm going to work through this pretty quickly so we can get to the next example. And the number term is still on the other side of the equation, so you don't really have to move it anywhere. You should have gotten x minus 9 squared, because half of negative 18 is negative 9. Half of negative 10 is negative 5, so that's going to be in the squared. That means you have to add 81 to both sides for the negative 9 from the x terms. Add 25 to both sides because negative 5 squared is 25. And when you add negative 6, 81, and 25 together, you get 100, which means your center is at 9, 5, and the radius is 10. Hopefully you did that just as well as I did. Now let's look at letter C. Letter C, notice for all the ones we've been doing so far, we've been dealing with just an x squared, just the y squared. No 2x squareds or 2y squareds. So it might be helpful if we can get rid of that 2 in both of these. So what I'm going to do is I'm going to notice, first off, that every term is divisible by 2. So if I divide everything by 2, that's a valid step to do because you can divide both sides by a number. So that gives me x squared plus 2x plus y squared minus 2y is equal to 7. Now we're going to apply the completing the square method that we since we have an x squared and a y squared and no numbers in front. So completing the square, group the x's together, x squared plus 2x. Group the y's together, y squared minus 2y. Add your plus blanks. So go to 7 plus blank plus blank. Again, the number term is still on the right side, so we don't have to move it. Been very lucky not having to move it just yet. So let's set up our perfect squares. Half of 2 is 1, so I'm going to add 1 to the x. Square the 1, you get a 1. Make sure you add it to both sides. Half of negative 2 is negative 1, so square that, you still get a positive 1. And add 1 to both sides as well. So 7 plus 1 plus 1 is 9. Your center is negative 1, positive 1. And your radius is 3. Just as easy as that. So go ahead, pause the video right now, and try letter D. Okay, so hopefully you've noticed that every term is divisible by 5. And we want to divide everything by 5 to make sure we have just an x squared and a y squared. So doing that gives me x squared minus 14x plus y squared minus 4y plus 52. And divide 0 by 5, we get 0. Now let's group our x's together and our y terms together. X squared minus 14x, add a blank. Y squared minus 4y. Add a blank. Aha, here now we have to make sure we add that 52 to the other side. So in this case we're subtracting it from both sides. So minus 52 plus blank plus blank. I'm going off the page. Alright, so now let's set up our parentheses to complete the square. Since we have negative 14 in front of the x, it's going to be minus 7. Square that means you're adding 49 to both sides. Half of negative 4 is negative 2. So square that, you get 4 to add to both sides. So adding the negative 52, the 49, and the 4, that gives us a 1. Which means our center is at 7, 2, and our radius is 1. Alright, pause the video now and write down anything you need to before going on to our last example. Okay, and the last thing we're going to do in this lesson is looking at an application of circles and lines. And sometimes you're going to ask to find the solution to the system of equations graphically, meaning you have to graph both equations on the grid and find out where they intersect. And the coordinate points where they intersect are going to be your solutions. Looking at both equations, the first one you should notice is a line. The second one is a circle. And they're happy lines and happy circles. Okay, so what we got to do is we got to graph our line. That one's pretty easy. That's already written in slope-intercept form. So the slope is the number in front of the x, so it's 1 over 1. And the y-intercept is the number term, So it's going to be negative 1. So I'm going to start at negative 1 on my graph, plot that point, and I'm going to plot as many points as I can. And of course, you're going to use your straight edge. Don't really have a straight edge on this iPad that I'm using. So you're going to have to excuse my freely drawn line. Of course, yours are going to be better than mine. So there are all the points. And I'm going to draw my line, and I'm actually going to label that line. We're going to have multiple equations on this graph, so it's good to label at least one of them. It may be a little harder to label the circle. Alright, now this circle, in order to graph it, we need to know the center and radius, which we don't know. So let's find it out. Let's group the x squareds together. Oops. Add a little blank. Group the y terms together. Add a little blank. Hey, the number terms by itself, so we don't have to worry about that. So we got to take half of negative 12, which is negative 6. Half of negative 8 is negative 4. Now we got to complete those squares to make sure we have a perfect square trinomial. So negative 6 squared is positive 36. Add that to both sides. Negative 4 squared is positive 16. Add that to both sides. And then find out what you get when you do negative 27 plus 36 plus 16. Hey, look at that. Still another perfect square. By the way, for today's lesson, we're dealing with nice, easy problems with completing the square. So if you end up with a number here that is not a perfect square, you might want to go back and check your work somewhere. Okay. So now we have the center of the circle is 6, 4, and our radius is 5. So let's graph this circle. Let's start by plotting the center point, 6, 4. Now notice, by the way, that that center point is not an actual point on the circle. So if it ever intersects the line, it's not a solution. Only the points that are on the outside of the circle, so those points right there, are going to be the points you're going to include in your solution for these problems. Radius is 5, so I'm going to go up 5 from that point, that center point, to mark a point on the circle. Left 5, down 5, and right 5. Now you may notice that none of those 4 points went through my line. You may also notice that this circle is a radius of 5, which means we can apply that little trick that we looked at in exercise number 3. We can apply that 3, 4, 5 right triangle to plot 8 more points, to make a 3, 4 triangle and a 4, 3, to apply more points. Let's do that. From the center point, go over 4, up 3. Okay, that's not on my line. Over 3, up 4. Hey, look at that. That's on the line. So that's going to be a really crucial point. And let's do the same thing for the remaining 8 points in the bottom right quadrants. There's no points added there. Bottom left. Hey, there's another point right there. And then in the upper left, there's going to be no points there. You might be able to figure that out by just looking at it. So drawing the circle in, you'll find out that the graphs intersect at this point and this point. I know we drew a graph for a circle, but it helps sometimes to circle those points. So all we have to do for our solution is just to write the coordinates of those 2 intersection points. So this bottom left one is 2, 1. Make sure you're careful about where the axes are. Make sure, especially when there are some darker lines like right here and right here, don't get confused about where those axes are. So make sure you plot the coordinates correctly. So 2, 1, and then 9, 8. Now because we saw this graphically, there's no need to really check into the original equations to make sure they both work. But if you look at the line, x minus 1, 2 minus 1 gives us 1, 9 minus 1 gives me 8. And if I were to plug into the equation of a circle, they will both work as well and give me negative 27. So there's your solution to this system of equations. Pause the video now and write down anything you need to before moving on. before we move on, I just want to point out one more thing. Now, you could have used your compass to draw that circle, and it would have been really a good circle to use. So if you forgot that 3, 4, 5 triangle, it would still intersect those points. Now, your compass has some error to it, so it might intersect just above or just below, just to the left or right. Okay, but so if it intersects at nice integer points, that's typically what's going to happen. Okay, so you can kind of almost assume that's going to be nice integer points. There might be some cases in the future, as we prepare for the Regents exam toward the end of the year, that might not be the case, but we'll worry about that at the end. So before you begin your assignments, I want to make sure you know how to complete the square without me doing it for you. So just take a moment and find the center and radius of this following circle. Alright, if you got -5, comma, +1 as the center, and the radius of 6, you are good. Alright, so I want to thank you for watching my videos. This is the point where you should start raising your hand to get the assignment from the substitute. Feel free to work on the assignment or quiz corrections, but make sure you're working for the rest of the period until the bell. Until next time, thank you for watching. Keep thinking and keep solving problems.